Okay, let's talk about how we would find the inverse here. So the very first thing we would do, set this y equals 3x plus 2. Or 3 to the x, not 3x, 3 to the x, okay? How would we find the inverse? We're gonna, first step, swap the x and y. So we have x equals 3 to the y plus 2. We want to solve for y. Subtract 2, good. X minus 2 equals 3 to the y. How do we get the variable out of the exponent? We use the definition of logs. Log base what? What's our base? 3. Of what? Equals y. Excellent. So this is the inverse, is log base 3 x minus 2. We were talking about how to do the check, and I didn't have room, so I'm going to do it on extra paper. We take the original function. If we check, we should be able to do the composition of the functions with the inverse should undo to give us x, okay? That means if I plug this in to the exponent, everything should undo. Okay, so let's try that. 3 to the power of log base 3 of x minus 2 plus 2. Now we haven't really talked very much about the properties of exponents, or the properties of logarithms, I should say. We've done a lot with the properties of exponents. So this might not make a lot of sense right now, but essentially what happens is 3 to the log 3, these are inverses of each other, so they undo each other. So what we get is x minus 2 plus 2. That's going to make more sense after we do the next lesson. And then what's x minus 2 plus 2? Is just x. It should work the other way too, though. The inverse of f of x should give us x. And this one, I think, will make a little bit more sense to you. So if I take the original f of x function, which was back here, and I plug this in for x into the inverse, that will look like this. Log base 3, oh yeah, scroll up, sorry. Log base 3 of, now I'm plugging that whole thing in for x. So that was 3 to the x plus 2, and you notice it already has a minus 2 inside. Okay, how would I simplify that? These cancel right here, don't they? Inside, if I start inside parentheses, what's 2 minus 2? 0. That was an inverse. Log base 3 of 3 to the x. Well, remember, if I'm using the property of logarithm, this is asking me 3 to the what power gives me 3 to the x. What would have to be the exponent on the 3? It'd have to be x, right? In order for them to be equivalent. So the whole point is that they undo each other, and I think as we get into the properties of exponents, or I mean the properties of logarithms, it will make a little bit more sense, some of these rules and why it works this way. But the most important thing is check it. For me, I care if you check it one way. So check it the way that makes the most sense to you right now. Just to make sure everything undoes and inverses it